So now the video that I am going to create is the video about Atwood Machine, the four problems that we answered in class. Just in case you didn't catch it in class, watch this video. Okay, for the Atwood Machine, we did a lab about this one also. We have seen that Atwood Machine is a system wherein you have a pulley and you have two masses hanging on the pulley. And remember that in this Atwood Machine, we are assuming that the pulley and the string are massless, and there is no friction. Alright, so it is our ideal pulley. Okay, let's answer number 1. Two objects of mass 1 and mass 2 with M2 is greater than M1 are connected by a light inextensible cord and hung over a frictionless pulley. Both cord and a pulley have a negligible mass. For A, find the magnitude of the acceleration, and B, if M1 is 5 kilograms and M2 is 10 kilograms, calculate the acceleration of the system and the tension of the string. Okay, so for letter A, we don't know the values of mass 1 and mass 2. We are going to solve it in terms of M1 and M2 only. Okay, first thing that you need to know is at what direction it is going to accelerate. So if you're going to look at this one based from the given, we said that M2 is greater than M1. So if M2 is greater than M1, it means this pulley is going this direction, right? It's going up and going that direction. And we know that our acceleration is going that direction. Okay, so in the video that you have watched, based on the video that you have watched, he is taking into consideration that the direction of the acceleration will be the positive direction. Okay, but for this problems, what I'm going to do is I'm going to treat the going down is always positive, always negative, and going down is always negative, and going up is always positive. Okay, that's what I'm going to do in this problem. Okay, so how are we going to do this? You can do a free body diagram separately on M1 and M2. So let us say for M1 first. M1 is, we know that there is a tension pulling M1, and then there is acceleration, force of gravity, which is M1G. Okay, be careful on labeling your subscript, because if you don't label it properly, you will get a different answer later on. Okay, so we know that for this one, the acceleration is going upward. Okay, so if we're going to do this one, we know that there is an acceleration that is going upward. We need to get the net force for this system, for our M1. And then we know that it is equivalent to the tension, which is going up, minus M1G, because acceleration due to gravity, the force of gravity is always going downward, and there is an acceleration that is going upward. So I just put it as positive value. So let us put this one as our first equation. Okay. Next, make a free body diagram for your M2. Okay, so for your M2, we know that there is a force of gravity going downward, and there is a tension going up. The tension for M2 and tension for M1, this tension right here, we're assuming that they are the same. Okay, we are assuming that whatever tension here will be the same as the tension right here. Okay, so going back here, our M2 is accelerating downward, so our acceleration is going down. So if our acceleration is going down, let us calculate our net force, which is equivalent to our my, because there is m8, because there is an acceleration. So going up will be positive t, going down will be negative m2g, and here, since the acceleration is going downward, I will put it as a negative m1a, because, or m2a, because acceleration is negative. Okay, and then after that one, what I'm always doing is just making this m2a positive by multiplying both sides by negative 1. So if I multiply both sides by negative 1, this will be negative t, positive m2g, and then m2a. Okay, and then I will make this one as my um, equation 2. Then the next thing that you need to do, combine equation 1 and equation 2. Okay, so we write equation 1 right here. T minus m1g equals to m1a. And then our equation 2 is negative t plus m2g equals to m2a. Okay, combine them. If you combine them, you will see that this t will cancel because this is positive t and this is negative t, and then there's nothing else that will cancel. So write down what is remaining. So I have m2g, I have m1g minus m1g because it has a negative value, and on the other side I have m1a plus m2a. All right, and then now here we are calculating for acceleration. So here you will see that there is acceleration here and acceleration here. Let us remove it, or let's put it out of our, let's put it out. Okay, and then it will be like m1 plus m2. Okay, so I just put out the a from these two terms. All right, this is just algebra. And then again, we are solving for a. So next step, divide both sides by m1 plus m2. So this will cancel, m1 plus m2. And then now my acceleration would be a is equivalent to m2g minus m1g over m1 plus m2. Okay, you can stop here, but sometimes in the multiple choice they are not really writing it like this form. This is also equivalent to a equals to g m2 minus m1, then put it on the parenthesis, divided by m1 plus m2. So both of these, the top one and the bottom one, they are the same. Okay, and that is our letter A. That is our acceleration. All right, next, letter B. What if 5 m1 is 5 kilogram and m2 is 10 kilograms? Calculate the acceleration of the system and the tension in the string. Okay, so here we just need to plug in our values here. So let me just erase this one so that we have space. Okay, so this is the equation for the acceleration. For letter B, it said m1 is 5 kilograms and then m2 is 10 kilograms. I'll just plug in the values. A is equivalent, I will use the second one. It's 9.8 meters per second squared. Multiplied by m2 is 10 minus 5 kilograms m1 divided by 10 plus 5 kilograms. And then if you solve this one, the A that you're gonna be getting should be equivalent to 3.27 meters per second squared. Okay. Next, number 2. For an Atwood machine consisting of 1 kilogram mass on the left side and 1.5 kilograms on the right side, calculate the acceleration of the system and the tension in the string. Okay, so let's do the same thing. Which way it will fall down? Is it clockwise or counterclockwise? We know that this one is heavier, and just thinking logically, that we know that once we release this one, this will go this direction. So your acceleration is going this direction, and this will go up. Okay, so like the same thing. Draw the free body diagram for each of your system, or for each of your masses. So let's put for 1 kilogram mass. Let's put this one as well, let's just put that's 1 kilogram mass. Okay, so we know that that is mg, so I'll just put it as 1g, 1 times acceleration due to gravity, and then there's a tension going up, and I know that the acceleration is going upward, so my acceleration will be positive. So just the same thing, net force will be tension going up positive, and then 1g minus, it's negative because it's going downwards. And since my acceleration is positive, I can put that will be m1, which is 1, multiplied by acceleration that is positive. And this is my equation number 1. Okay, next. For my equation 2, I'll just put it as red so that it's a different color. For my 1.5 kilograms, okay, I know that its force of gravity is mg, so the mass is 1.5 times acceleration due to gravity, and there's a tension going up, and then the acceleration is going downwards, so I have a negative acceleration. All right, so here again, both of the tensions are the same, so same thing. Tension is going up positive, and then this one is going downward, so it's 1.5 g, equivalent to mass times acceleration. Our mass is 1.5 and acceleration is negative, so I'll put a negative sign there. Okay, like we did in number 1, multiply both sides by negative 1, so this will be negative t, this will be positive 1.5 g, and then this will be a positive 1.5 a. Okay, and this is our equation 2. Now, the next thing that we need to do is to combine equation 1 and equation 2. Combine 1 and 2. Okay, equation 1 is t minus 1g equals to 1a. And equation 2 is negative t plus 1.5g equals to 1.5a. And then combine the two, add the two. I'll put it as black. Okay, tension will cancel because one is positive, one is negative. And then combine these two. It's 1.5 g minus 1g equals to 1a plus 1.5a. And just algebra. 1.5g plus 1.5g is 0.5g, right? And then 1a plus 1.5a is 2.5a. Okay, and I need to calculate for acceleration, so divide both sides by 2.5. 2.5. A will cancel, then I will have 0.5g all over 2.5. And we know that g is 9.8 meters per second squared divided by 2.5, so our acceleration should be equivalent to 1.96 meters per second squared. So here, that's your answer on letter A. Okay, for letter B, I'll make it the blue color. We need to find the tension. Okay, since the tension in this and this one are the same, we can use either equation 1 or equation 2. I'll be using equation 1. You should come up with the same answer. Okay, so rearranging the equation, t would be equivalent to 1a plus 1g. 1a, it's our a that we calculated is 1.96 plus 1 times 9.8, our acceleration due to gravity is 9.8, and then just solve everything. This should be equivalent to 11 point it should be 11.76 newtons. So that is our tension. Okay, let me just go back to number 1 because I think in number 1 we need to calculate for the tension also. I just calculated the acceleration. Okay, so for number 1 it will be the same thing for the tension. We can, if you recall the equation that we have, For letter A, our tension, I will be using the equation 1 that we have right here. It will be T minus M1G equals to M1A, and then T is equivalent to M1A plus M1G. And then they said our mass 1 is 5, and then the acceleration that we calculated is 3.17 plus 5 m1, and then 9.8 is the acceleration due to gravity. This should be equivalent to 65.33 newtons. Okay, forgot about that. Okay, next, number 3. It will be the same thing. Two masses hung from a frictionless pulley by massless spring. If M1 is 5 kilograms and M2 is 70 kilograms, what is the acceleration of the system and the tension in the string? Okay, so it's just the same thing, but this time we do not have a drawing because I would like you to know how to draw. We have two pulleys. Okay, let's say our M1 is 5 kilograms. And then our M2 is 7 kilograms. And we know that based from this one, this is heavier than the other one. It will be accelerating this direction. Okay. So next thing, draw a free body diagram per mass. Okay, I will do this M1 first. So Fg, which is equivalent to mg, and our mass is 5, and acceleration due to gravity is g. There's tension going up, and then we know that the acceleration is a positive acceleration. So we know that our net force would be equivalent to T minus 5g, equivalent to mass is 5 and acceleration is positive, and this is our equation 1. Okay, next, for 7 kilograms. Okay, 7 kilograms, so that will be 7g. mg is for the force of gravity, and then tension is going up, and we know that the acceleration is going downward, so that we're going to have a negative acceleration. So the net force will be T minus 7g, equivalent to m, which is 7, and then our acceleration is negative, so I'll have a negative ma. And again, we can change the sign by multiplying both sides by negative, so this will be negative T plus 7g equals to 7a, and this is our equation 2. Okay, next, combine equation 1 and 2. Alright, so T minus 5g equals to 5a, that is our equation 1. Equation 2 is negative T plus, that's negative, plus 7g equals to 7a. Combine it. If you combine it, this will cancel, and you're left off with 7g minus 5g equals to 5a plus 7a. Alright, so subtract the 2, that will be 2g, and then add the 2, because 5a plus 7a, that will be 12a. Okay, and if you want to calculate for a, divide both sides by 12, and our a would be equivalent to 2g divided by 12, wherein 2 is multiplied by 9.8 divided by 12. Our answer should be 1.63 meters per second squared. Okay, so that is our a. Next, letter B. What is the tension in the string? So again, just choose which equation you want, whatever equation you want. I will be using equation 1. T minus 5g goes to 5a. And then t, rearranging the equation, is equivalent to 5a plus 5g. And substitute the values. The a that you calculated is 1.63. 5 times 9.8. And if you solve for this one, your answer should be 57.15 newtons. Alright. Okay, next, last number, number 4. Two masses M1 and M2 are connected by a light string over a massless pulley as shown. So this one, it's the same. The only difference is M1 is on a surface. Okay, but the process is exactly the same. Okay. Letter A, assuming a frictionless surface, so frictionless, there's no friction. Find the acceleration of M2. And then if M1 is 5 kilograms and M2 is 2 kilograms, what is the acceleration of M2? Okay, so here I asked that what is the acceleration of M2, but since it's frictionless and they're on the same, we're assuming that the pulley is massless, and the string is massless also, and there is no friction on the pulley. We can say that the acceleration of M1 and M2 is the same, so it doesn't matter which one we calculate. We're just going to have one acceleration. Alright, so for this one, we'll see that we know that since it's frictionless, we will know that M1 is okay, hold on a second. Okay, so it will be the same process. We know that this one will gonna fall down this direction because it's frictionless, and it's like, this one is hanging, so it will go this direction, and this one is going that direction. Okay, so it will be the same thing. Draw a free body diagram for each of the masses. So let's start with this one. We know that for mass 1, there is a tension pulling that direction, and since it's on the surface, there will be normal force. And then when we're going, there is like force of gravity, which is m1g. Alright, this one is frictionless, so there's no other forces present on it. But later on, if there is a friction, then you should be adding some kind of, if it's moving this direction, you need to add some friction going this direction, on the opposite direction. Okay, so here, this is our free body diagram for this one. Okay, now get our net force. So this one, if you look at this one, your Fn is equivalent to m1g. Why? Because we know that it's not accelerating up or down, it's just accelerating this direction, right? Your acceleration is only going that direction. And if you're only going that direction, it means you don't have net force on the on the vertical component. You only have a net force that is equivalent to T. So your net force is equivalent to T, which is equivalent to MA, which is M1A. And this is our equation 1. Okay, next, for M2, we have this one that is going this direction, which is the force of gravity, so that will be m2g. And this one will be the tension. And then we know that it's accelerating this direction. Okay. So where is it? Okay, so it's the same thing. Let's assume that it's the acceleration is going downward. So our net force would be tension net force is equivalent to tension minus m2g is equivalent to m2a, and I do have a negative acceleration, so that should be a negative, and remove that negative sign by multiplying both sides by negative value. So you have negative t plus m2g equals to plus m2a, and this is our equation 2. And combining these two, combine equation 1 and equation 2. Our equation 1 is t equivalent to m1a, and our equation 2 is equivalent to negative t plus m2g equals to m2a. So it will be the same thing as earlier. These two will cancel, and what is left on this side, it will be m2g. And on the other side, you have m1a plus m2a. And like earlier, I will put out my a, so we'll have m1 plus m2. And I need to calculate for a, so I need to divide both sides by m1 plus m2, m1 plus m2, and then these two will cancel. So my a is equivalent to m2g over m1 plus m2. Okay, next, if m1 is 5 kilograms and m2 is 2 kilograms, what is the acceleration? So just plug in the values. So our a is m2g over m1 plus m2. Our m2 is 2 kilograms multiplied by acceleration due to gravity. And then our m1 is 5 kilograms, m2 is 2 kilograms. Then if you solve everything, you should have 2.8 meters per second squared. And this is your... Okay, that's it.